Hi and welcome back to another code video. Today we're looking at dynamic programming problem 647 palindrome substrings, and we're given a string s and should return the number of substrings in it. So a string is a palindrome when it reads the same as backwards and forwards, that, and a substring is a continuous sequence of characters string. All right, so we are having here. We are given the string ABC, the number of palindromes, and every single character is a palindrome. So that's how here we have the extreme example where every substring is. Here is we count the same substrings multiple times when it originates from different positions. String. All right, so in the previous example where we determined the maximum palindromic substring, we already kind of had a way to check whether substring S is a palindrome or not. So I think we're just going to use the same approach. So instead of using a dynamic programming one, we're just going to use a two-pointer approach where we iterate over all of the different positions in the string and try to expand from there to the left, to the right, until between left and right, it's not a valid palindrome anymore. And every time we do an expansion and it's still valid, we can increase the counter because we found another palindrome. And that way we also guarantee to never find exactly the same strings, or not the same string originating the same left and right, well, within the same boundaries. So let's do that. So we're going to have, we need a little helper function here, def count, and we're going to give it a left and right pointer to start from. And by default, we're just going to assume that, well, we have one character in it. Oh, we don't actually have to return the maximum, so we just need to return a count, right? Count is equal to. All right, we're going to flesh out this a little bit in a, but now let's just write the outer loop for I in a range string. Now we have result variable, turn it at the end, and in between we need to update our result variable counts that we get by calling palindrome. Things. Right. Result plus equals on palindromes when we start at for odd length palindromes, and then we have to do even length. That's everything we need here, and it's going to be an O of n times n time operation. And well, if let's see how much space we will need to get away with using constant space. Have a little while loop. While left is or equal to 0, and right is the length of the string. That is the case. You can perform a comparison. String at character and string at the left position is not equal to character right position. Oh, we're done. We can break out of our loop. Otherwise, it means we're going to increase our counter, and we are going to update our 2 pointers. 1. Right, so every time we're able to expand our string, that means we've found a new palindromic substring in S, and iterating over all of the different start positions, it's guaranteed that all of them are going to be different. So I think that's all it takes to solve this problem. Let's just try to run it. typing mistakes. No typing and apparently mistakes, at least for the test cases. So now let's submit this. And it passes it. So yeah, so I guess the takeaway is that even though this is a dynamic programming problem, if there's another technique, just use that other technique. And in this case, this technique only requires constant space because we're not storing anything except for a left, a right, count, and a result variable. That concludes the video.